Hi, everyone. How are you doing? Please turn on your camera. Okay. Um, First of all, I would like you to know that we will have a test on December the 17th, which will cover chapter 1 through chapter 6. Okay. Chapter 1 through 6. That's the final for the first term. And then our second term will begin after Christmas. And the final for the second term will be on February the 25th. So the week after next week will be the final for the first term. Okay. Before that, we will have a brief review from chapter 1 through 6, mainly about classes. That's about chapter 3, 4, 5, and 6. So if you have any question about the homework, projects, you can let me know before next class, or you can join the homework club on Sunday. All right, so about this project during the Thanksgiving break, I only checked a few of your submission. I think many of you did very good job. And I like your README doc that's very clearly explained. So I want to briefly go through the project because we still have several students haven't turned yet. I guess you might have some difficulty with that. So we'll discuss about it. And then if you still have question, please let me know either through email or comment in the Google Classroom. Okay, so all right. I had made some mistakes in this doc. I'm not sure if that caused you some confusion. First of all, is this chart. At the beginning, I made 75 or 76 entries. It should be 70. So yeah, 70 questions, 70 answers. And these 70 questions are grouped into 4 different groups, right? Each corresponding to one dimension. The question labeled ones belongs to dimension 1. And the question labeled twos belong to dimension 2, and so on and so forth. So you see, each cycle we have 7 questions, right? The first question in one unit or one cycle is related to the first dimension, and the following 2 questions belongs to the second dimension, right? And the following 2 belongs to the third dimension, and the last 2 belongs to the fourth dimension. In the end, you will need to summarize the answers in each dimension, right? All the answers belong to the first dimension, and need to count how many B's are there, how many A's are there. If the B's is more than 50% of the total answers, then that dimension would, you need to choose, sorry, I guess the first or the second, let's see. If it's less than 50% responses, for B, you need to choose the first, right? If less than 50% B responses for a given dimension, then that type would be the first of the two choices. Otherwise, that's the second choice. Yeah, I made some mistake here, and I also made some mistake maybe here. 90% B, it should be the second choice. It should be E instead of I, but I originally put an I here. So that's a mistake, but I guess it won't. Yeah, I'm sorry if that caused you some confusion. Yeah, that's the brief introduction for the project. So your goal is first to implement this whole program, which can take in 70 answers from the user, right? And store that 70 answers either in array or several arrays. And then you need to analyze the answers, right, in different dimensions. And then give the report in this format. That's the goal for this program, okay? So in order to take in the user input, you might need to use a scanner class or other input-output classes. We would suggest scanner, okay? And then in order to store the answers, user input, you will need either a string array or a char array, right? That doesn't matter because the answers is basically one letter long. So it could be a char array. It could also be string array, doesn't matter. You can use 4 arrays, each corresponding to 1 dimension. That's okay. You can also use 1 single array, right? And then you need to figure out which question, right, belongs to which dimension. All right. For example, I use 1 single array. Let's say the array's name is answers or result. Answers. Okay. And that array, let's say it's a string array. And the size of the array is 70. So when you initialize it, new, right, a string array, and you need to specify its size. It takes in 70 answers, so the size is 70. Okay, if you're using 1 single array. Okay, so in the end, after you store all the answers into this array, maybe using a for loop or a while loop, sorry, let's say a for loop, right? A for loop that take in 1 answer each time and using an index I from 0 all the way to 69, right? And then you store the answers into this array 1 by 1. And after that, you want to analyze the answers in the array. And you need to figure out, right, which entry, which element belongs to which dimension. According to our analysis, each unit has 7 questions, right? So 7 questions, 1 unit, 7 questions, 1 unit, okay? And the first questions in this each unit belongs to the first dimension. And if you look at the index for these elements, the index are 0, 7, 14, 21, and so on. All are multiple of 7, right? So you can use a mod. Let's say index, another for loop. Index I mod 7. If the remainder is 0, that means this question belongs to dimension 1. And you need to count how many B's, right, are there, how many A's are there. Okay, that's dimension 1. For dimension 2, the indexes of the elements are 1, 2, 8, 9, right? 15, 16, 22, 23. So again, I mod 7, this time the remainder would be 1 or 2, right? 1 or 2. 1 or 2. So these following questions belong to the second dimension. You need to analyze all those elements, right, from the array and see how many B's are there. Okay, similar for the following 4 questions. Okay, that's one way if you store all the answers in one single array, right? That's how you analyze based on the indexes. If you store answers into 4 different arrays, you can do it differently. For example, you can use separate for loops, 4 different for loops. The first for loops is belongs to the first dimension, but you need to tell the user, right? The following, let's say, 10 questions. The following 10 questions, all belongs to the first dimension. Okay, it's not, the questions are not given in order, but given in different groups, right? In different dimensions. So that also works. You take in the first 10 questions that belong to first dimension into one array, and then another for loop that take in 20 other questions for dimension 2, right? And then another 20 question for dimension 3, and another 20 for dimension 4. And you store the answers into 4 different arrays. And then in the end, when you analyze the answers, you just need to count, right? How many B's are there in 4 different arrays, right? So at the very end, after analysis of those answers, you just need to put out the report in this format. How to print that? Well, you can use a string variable, let's say result or report. Initially, it could be an empty string, right? Then first attach the name to that. You should read in the name of the user. And by appending the name onto the report, right? And then a \n, that means you start a new line attached to the string again, and then attach this result, right? 1A, 9B. These numbers are recorded in your analysis of the answers, right? So you record that numbers and attach it to the report, all in string form, right? And then the third line, another new line. The third line is, just the percentage of the A, B responses. Okay, and finally, some if-else statement, right? If it's greater than 90 degree, it's greater than 50%, we attach an E, otherwise we attach an I, right, onto the report. So that's the very last part when you organize the report. A report could be one single string. If you don't want it to be a one single string, you want it to be separate lines, That also works. You just first print out the name, right? And then the second line, another print line function, print out this result, right? A third system print line function to print out the last line. That also works. Okay. All right. So any question about the project? Especially for those haven't turned in the project yet. No, no question. I would suggest you to implement two different classes. One class is this personality test that has private instances and several public methods, right, to support this test. That's a one single class. Another class is used as a driver class that only has the main function, okay? So I would suggest you to separate these two. One driver class, another is the personality test class. Okay, so when you test your program, you don't need to input 70 answers into the array. That would be very time consuming. So when you test your program, you can just use an array, right? Initially given array, right, to test it. For example, like this. So in real situations, you will need to use the scanner to take in the results. But when you test your program by itself, you can just use a string array or a char array like this, right? Pre-constructed. You don't need that. This part actually does the same thing. After the for loop, after taking in the 70 answers, you will have an answer array like this. But when you test it, you just need to use that, okay? And this is just the driver class, which only has the main function. So in the main function, you basically use a scanner to take in the result, take in the answers, right? And store the answers into the array, right? And then construct a new personality test class, an object, right? A new object, and then just run, just return the result. And every instances method should be in the personality class like this. So you should have some private instances, right? And some supporting methods. Here I have a very simple constructor, which basically initializes the arrays. And my toString function is used as the reporting function. Okay, so yeah, that's the part you need to customize actually. That's the part how you analyze the answers and how you organize the format of the report. So in the end, I only called the toString function. You can do it differently. I don't need to copy mine or follow mine structure. I saw some of you using char arrays, right? taken in the yeah, because there are too many ways to implement it. The basic idea is this. So I don't know what specific questions that you have during your project. If you don't have questions, then I just move on. We'll finish chapter 6 today. We only have one part left. That's about array list. And after that, I would like to review this chapter a little bit and then do some practice together. I don't want to go too fast because I think some students might still have difficulty with Java classes, and some even have difficulty to debugging your program. So I'll give you some more time to familiarize with that. Okay. All right, if you don't have question, we'll stop here. I'll try to finish the chapter first. So last time we discussed some sorting, searching algorithm, right? That part, not advanced, but not that frequently being tested in AP exams. You will not be asked to write the entire selection sort algorithm or insertion sort algorithm in the free response questions, but you might see them in the multiple choice. You need to understand what the algorithm is doing, okay? And you need to know how to analyze the time complexity of that algorithm, okay? For searching algorithms, the linear search algorithm is required. Definitely, you will need to know how to implement that. And we actually have been using that a lot, right? It's basically just a for loop, looping over the array, starting from the beginning all the way to the end, or backward from the end to the beginning, right? One by one. So that's a very simple searching algorithm you must need to know. The second searching algorithm is binary search. It's applicable only to a sorted array. If the array is not sorted, that's not workable. Only when this array is sorted, we can use the binary search to search for a single element or target in the array. And that is much more efficient comparing to the linear search algorithm. Okay, you need to know the basic idea. If you find it hard to implement it by yourself, you can just let it go. But you need to know the basic idea, right? The basic idea is, since the array is sorted, we don't need to compare the target with each element from the array one by one. We just need to go directly to the middle element of the array and check that with the target. If the target is less or greater, right, we just need to abandon the other half of the array and focus on one half of the array. And that way we can shrink the size of the array in half and in half and in half until we find the target. Okay, that's the idea, high level idea. All right. For selection sort, insertion sort, yeah, you also need to know the idea of that and also the time complexity. Okay. I will review that after I finish the array list then. Okay, we also discussed about comparing sorts, because if the array are to be sorted, right, we need to know that the elements are sorted in what standard, in what order, right? If the array is just a integer array or double array or a string array, there's a definite way to sort it, either in descending order, ascending order, right? But if the array is an object type of array, a user-defined type of array, then that type, let's say a student type or a personality test type, right? In that class, it must have some function, we call it compare to function, that defines the way to compare the order of different objects. If that is not being implemented in that type of class, there's no way to sort this type of object. Okay, so in order to sort an object type of array, that object class must implement the comparable interface. That means it must override the compare to function. Okay, it must define some way to order the objects. Okay, let's say a student class ordered based on student's first name or last name, right, or GPA or anything. Okay, it must define some order. Okay. Hashing is not required, so I just put it aside for now. Two-dimensional arrays. I think I mentioned it last time. It's very similar to one-dimensional. It's just in order to position one element in the two-dimensional array, we need two indices. One specify which row it belongs to, and one specify which column it belongs to. So two indices instead of one index, right? For one-dimensional array, we use one index, let's say I, starting from 0 all the way to array length -1. But for two-dimensional arrays, we need two indices. One is I, one is J. Okay, so let's say we have an array scores, right? Scores that has 12 rows, 50 columns. So that's row and column, row number and column number. So it's a 12 by 50 array. Okay, 12 by 50 array. The first index specify the row number. The second index specify the column number. Okay, so like 3 and 6, that's in row whose index is 3 and column whose index is 6. All right. If we look at the two-dimensional array, so that's score, it's an integer array, two-dimensional array. If we look at that, you can actually look at it in another way. Instead of a two-dimensional array, It's actually a one-dimensional array whose elements are also arrays. Okay, so a two-dimensional array can be seen as a one-dimensional array each element is also an array. That's one way to observe it. So for example, this scores array, it's a two-dimensional array, right? We have, let's say, 30 rows and 50 columns. Okay, we can observe it as a one-dimensional array whose size is 30, and each element is also an array whose size is 50. So that's the first element in the array. Okay, that's the first element in the array, who is also an array. So if you write score 0, this will return the first element in the one-dimensional array, which is also an array. And the size of this one is 50 because we have 50 columns. Okay, so that's the first element in the scores array, which returns another, this is another array of size 50. Okay, and scores 1, of course, is also an array, also of size 50. Scores 2, also another array, size 50, right? All the way to score 29. Because for this one-dimensional array, it has 30 elements. Each element is an array of size 50. Okay, you can observe it differently, right? That's a two-dimensional array. So if you only specify one index, that index will be the row number, okay? And this will return another array, right? This will return this one single row, which is also an array. And the size is the columns number, okay? All right. So in order to traverse the two-dimensional arrays, we usually will need double for loop. The outer for loop is used to traverse rows, starting from row 0 all the way to the end, right? And the inner for loop is used to traverse columns, also starting from 0 and all the way to the end. That's a double for loop. This is the outer for loop and inner for loop. For any row, let's say row 0, that's the first row. For any row, we have 50 columns, right? 50 different elements in that row. So we need another for loop to loop over those columns, okay? You can also think of it as looping a one single array of scores whose size is 30 using a for loop. And in each element of the score, that's also another array. So we would need another for loop to loop over that one single element. And the size of that element in this case is 50. That's the column number. Okay, so usually we will need a double for loop to traverse the arrays. You can also traverse with other orders. Let's say I want to traverse rows from the end all the way to the beginning. So row will start from total row, let's say row number -1 all the way to the beginning. And the inward for loop may not necessarily be the same order. You can traverse the inward loop column from 0 all the way to the end or backward. That doesn't matter. So these two traversing order can be different or can be the same. It doesn't really matter. Anyway, after that, each element, each entry in the two-dimensional arrays will all be visited once. Okay, if we look at the time complexity, double for loop. The outer for loop loops 30 times, right? Because we have 30 rows. The inner for loop loops 50 times because each inner loop, right? That's 50 times. So it's 30 by 50, right? The time complexity in total, we would need 1,500 loops, okay, in order to traverse the whole entire array, right? Let's say if the size of the array is n by n, then the time complexity to traverse the entire two-dimensional array would be O n times n. That's the number of iterations needed to traverse the array. Okay, a double for loop. When we discussed the insertion sort and selection sort, we also discussed the double for loop, right? And the time complexity, if you still remember, for selection sort and insertion sort are both n squared. N is the size of the array, right? So it's very similar, okay? Because we all use the double for loop structure, okay? All right. That's array. And we know that array, when initialized, the size of the array is given and it's fixed. There's no way to change the size later on, right? The good thing for that is it's more time efficient to visit each element in the array, okay? We only need to give the index for the element, and then we can visit that element directly without any time delay, right? But the disadvantage is that if we want to add more elements later on, and if the size of the array is not enough, there's no way for us to add more, right? We have to create another larger size array and copy everything to that new array. That's not that time efficient. And if we don't have much element in the array, in case we would have more elements to come, we will create a large array at the beginning, which is a waste of space at the beginning, right? So there's another structure called array list. Okay, array list is also a class, part of Java util package. It's implemented already, so you just need to import that class to use it. Okay, array list also work like array. It stores elements in orders. Okay, so you can think of it as array, but it's different from array. The size of it is not fixed, so it's dynamic. Okay, it's more like a list, not like an array. A list means you can append things onto it and remove things from the list. Okay, but an array, that's fixed. Array list, it looks like array, but it has dynamic size. You don't need to specify the initial size. By default, the initial size of the array list in Java is 11, but you don't need to specify that. It will give you the default size. You can also specify a starting size, okay? And you can add more things onto it. The size of the array is automatically increased, or you can remove things from it, then the size will automatically shrinks. Okay, and you can also visit each element in the array list, just like that in arrays by using the index. Okay, but remember, once the item is inserted into the array list or removed from the middle of the array list, then the rest part of the array list would also be affected, right? If you want to insert something right in the middle, then the following half part of the array list will need to be removed in order to need to be moved, right? In order to make room for the new one. Or if you remove one single element from the middle, and the rest part will be moved, right? In order to remove the space, right? So that way, we don't need to worry about how it works. The array list class is defined by that way, and we just need to use some functions, and will automatically do things for us. For example, add new element or remove elements, right? You don't need to worry about that, but you need to know that it works like an array. It's just it automatically helps us to remove things from middle or insert things to the middle. But the time complexity is still the same as that in array, right? So like if you're inserting you want to insert something in the middle, then the rest part of the array will need to be moved backward in order to make room for the new element, right? That's where you insert that. In order to move the rest part, remember in array, we need to move it one by one, starting from the last element, right? Move it one by one. So all those elements will be moved. Although we don't need to do it manually, this add function or this remove function automatically do that for us. But the time complexity is still the same, right? It's just being encapsulated in that, but it's still there. We still need to move all the elements, right? To backward or to forward. Okay. All right. So comparing to time efficiency, it's similar to array. Okay. It's just we don't need to do it manually. And the size of the array is dynamic now. Okay. And there are also many other useful functions that you can use in array list. The first one is the constructor. That's used when you construct a new empty array list. Add, which returns a boolean that inserts a specified object to the end of this list, not in the middle, okay, to the end. But if you want to insert it to the middle, you need to specify the position of that. The first integer index is the position where you want to insert that to, okay? And the second one is the object. This returns a void. It returns nothing, okay? And then clear. Clear means remove all elements from this list. If you want to remove one single element based on the index, then just specify the index. this will return an object type that's the removed object. It will return the removed object. Get will get a specific object at this index. Index of will return the index of the first occurrence of the specified object. Okay, for example, I have a score array list. I want to check the index of score 100. That will return the first occurrence of 100 in the list. Okay, if that does not exist, then it simply returns -1. Contains. This returns true if this list contains a specified object. Okay. Is empty. Returns true if this list contains no elements. This function is actually very useful. Every time before we loop or traverse over the array list, we need to make sure that this array list is not empty. Especially when you are to remove some of the elements from the array list several times, we need to make sure, right, the array list, before you remove things from it, it's not empty. Otherwise, that will cause some exceptions, some errors, right? So this is very important. Size returns the number of elements in the list. Okay, the number of elements, not the size of the entire array list. Okay. Because the size of the array list is dynamic, so the size of the array list is actually the size of the number of elements in the list. Right? That's array list. Let's see. So you need to know one dimension array list that's similar to the array. You also will need to know two-dimensional array. For two-dimensional array, using array list, it usually would be something like a one single dimension array. For example, an integer array, score, but something, okay, let's say 10 or 20. But the element, each element of this array score is an array list. That's one way. So we see something like this. Because the array list size is dynamic, so it could be something like this. Okay. This is the single array. This is the single array. And the element in the array is, each element is an array list. And we know that the size of the array list is dynamic. So the size of each element of the single array could be different. Could be longer, could be shorter. Right? It doesn't necessarily to be the same. Because we can always append or remove elements from the array list. Okay, that's I use the rectangles to represent the array list. And this is the first array list, second, third, each have different size. They don't necessarily to be the same size. Doesn't like this two-dimensional array. In two-dimensional array, every row should be the same size. But if it's a single array whose elements are array list, then the size of each element could be different. Okay, so it's not a rectangle or something like that. The size for each row can be different. All right. Okay. You need to know that. And if that is the case, for example, we have a class who has a private instance that has that is a two-dimensional array. Okay, for each element, it's a one-dimensional array, and each element is an array list. Then in the constructor of that class, you need to initialize that private instance. To initialize that private instance, you also need to initialize each element of the array because each element is an array list. So we need to initialize every array list in the array using a for loop. Okay, that's the constructor. Later on, we'll see some examples. Okay. Yeah. For the efficiency, the array list class is implemented using an array. So in its structure, right, it's still array. It's just the moving elements around part is encapsulated in the functions defined in array list class. We don't need to worry about this, but to expand the size of the array list or shrink the size, we still need to move things around. So that part is necessary, okay? So the time efficiency of array list is still the same as array. If elements are added to or removed from the end of the list, then this process is fairly efficient because we don't need to move things around. It's just append a new element and remove a new element, okay? But if we need to insert and remove things in the middle, then elements are constantly being shifted around. That is not very efficient. So using array list may not improve the efficiency. It's just more friendly to a programmer. We don't need to worry about things shifting around, right? Okay. Now let's look at some examples. First of all, it's a two-dimensional array. This is a two-dimensional array. Scores. When you initialize this two-dimensional array, remember it's array of arrays, right? Array of arrays. When it's a one single array, we use one curly bracket and we separate each element with a comma. But since it's array of arrays, each element of this array is also an array. So that element should also be within the curly bracket, right? And then separated within by commas. So this is a scores array, two-dimensional. Each row has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 elements in one row. Another 10 elements, right? 10 columns in one row. In total, we have 4 rows. Right? It's 4 by 10 two-dimensional arrays. Okay, if we want to find the length of the score, this will return what? This will actually return the number of rows, right? Because this length returns the size of the outer array, right? For the outer array, it only has 4 elements. Each element is an array. So the size of the score array should be 4. It should return 4. But the size of the first element, remember scores 0, that will be the first element of the score, which is also an array, right? And the size of that, the length of that, will be the column numbers, which should be 10. Okay, so you can use scores.length to get the total row numbers, and scores0.length to return the column numbers, total row. Right, and the following one is total column numbers. Okay. And to traverse a two-dimensional array, we need a double for loop. Right? This is the outer for loop, traverse the rows. The inner for loop is used to traverse columns. So the outer index is soda, which ends at sodas -1, which is the row number -1, right? That traverse the rows. The inner loop traverse columns. Okay. You can also switch, right, these two for loops. If you want to make this for loop, an outer for loop, this one an inner for loop, that also works, but it's just the order of traversing the elements in the array is different. If we put the outer for loop that loops over rows, then the order each element being visited will be this. When row number 0, we loop the first column, or the first row, right? Starting from 3, 4, 5, 2, 1, 4, 3, 2, 4, 4, until the first row is visited, right? All is visited. Then we finish the inner for loop and go back to the outer for loop. The row number increased by 1, so we go to the second row and visit every element from the second row. So In this way, the elements in the two-dimensional array are visited row by row, right? Row by row, all the way to the end. But if you switch these two for loops, what will happen? For example, copy that again. Now switch the two. I'll make this an outer loop. I'll make this an inner loop. That also works, right? Theoretically, the time complexity will be the same because it's still every element should be visited just by once. So the time complexity is exactly the same, but it's just the order that each element is being visited is different. This way, the outer for loop is looping the columns. So for the column one, each rows will be visited. So it would be column one, each rows being visited. After that, we go to column two, then each row is being visited, and then column three. So it's visited, all the elements are visited column by column instead of row by row. That's another way. It depends on you. So these two are equivalent. Time complexity are the same, but the order is different. Okay. All right. Okay. Okay, so let's run it and see the result. It returns, determines, and prints the average of each row soda and each column respondent of the survey scores. So the average of each row, we need to add up, right, the elements in each row and then divide by the size of the row. The size of each row is just the column number, which is 10 in this case. How to find the sum of each row? Well, we just need to accumulate in the inner for loop, right? Because the inner for loop loops the columns in one row. So we just need to add up the sum and then divide that by the number of columns. Okay, so that's the averages for each row. And then these is the averages for each column. All right. Okay, let's look in details. This for loop, when we land on a specific row, let's say row 1, then soda sum, soda. This is the index, the outer index, which is the row index. Row index, now it's 0. It starts from 0. So soda sum 0 would be accumulated by the columns, each columns. Okay, Soda sum is also a single array that keeps the sum for each row. So this is the first row sum. When soda is 2, that's the second row sum. Okay. So initially that's 0, and at the score soda, which is the row index, and person is the column index starting from 0. So that's 3. After this is done, the second line, person sum, that's the sum for each column, right? Person sum, that's the sum for each column starting from 0, that's the first column, plus scores, soda, and person, right? Okay. All right. So after the first iteration, soda sum 0, right? Soda 0, soda sum 0 is equal to 3. Person sum 0 also is equal to 3. And the second loop, after that, person increased to 1. Soda sum still 0 is equal to scores 0, 2, 0, 1 is being added upon it. So the soda sum 0 now becomes 7, right? And the person sum, person now is 1. Person sum 1 becomes 4. Okay. I can use the debug mode to show you. The debugging mode is very useful to help you figure out the bugs in your program. You can just create a breaking point by double-click this line. This is a breaking point. So once you run this debug mode, the program will stop at this line, and then the following lines will be run only when you click it, right? So there are 2 buttons. One is step over, one is step into. I think I explains the ones. Step over is just running this line and step over it, right? Return the result. But step into will go into the functions for that line and see how that function actually works line by line. If you're not interested about the function itself, if you're only interested about what returns, then just use step over. If you're interested into the inward parts of that specific function, okay, then you can use step into. Okay, for now, I just use step over. So after step over, the first loop, we see that we have a score array that is of size 4, because that keeps the scores for each element in that score is also an array, right? The first array, right? This is the first array. The second array, right? In total, we have 4 rows, so 4 arrays. And soda sum also is of size 4. Each element keeps as the sum of each row. Person sum size is 10. That keeps the sum of each column, starting with all zeros. Okay, so now we land on line 23. Step over that. After stepping over 22 and 23, you see we created 2 local variables, soda and person. They both start from 0. Then we are now at 25. 25 would add score soda person, this element, onto soda sum. For now, soda is 0, person is also 0. So after that, let's see. After that, let's check the soda sum, 0. This highlighted one is the one just recently being updated. So now the first row sum is 3 because the first element 3 is being added to that. Okay, now we come to 26. After 26, let's check the person sum, the first one, right? That's the first column. 0 means the first column also is being updated. And then we go back to the inner for loop. Again, now after that, the person, this index, that's the index for the row for the columns, it's being updated to 1. Okay, and then run 25 again. After running 25, the second element in the first row, right, is being added upon that. So it's 7 now. 3 plus 4, that's 7 now. 26. Person sum 1 is equal to score 0, 1. So it's been added to the second column, right? 1 and 4. Okay. And keep going. Person increased to 2. So the sum increased also by another element. Person, the third column, right? And so on and so forth. Okay. After the first row is being, let me quickly do that. Nine. That's the first row. And 9. Right, 9. Okay, now person, right? We go back to 23 again, line 23 again. This time person increased to 10 and no longer less than 10. So we go back to the outer for loop where soda now would increase by 1, right? Soda increased by 1. Then we go to the second row, After running that, now the second row, right? It's the sum is stored in soda sum index 1. Okay. All right, that's how it works. I will not keep going then. Okay. That's this example. Let's see some array list example. In this main function, we created a new array list object by using new. I am calling the constructor of the class. The type of it is array list. Okay. And then we can use the add function to append new elements into the list. append that to the list. Right now, we have 4 elements in the array list and can print that out and see what's inside. So it's very simple. Just by calling print line band, we will print out all the elements in the list. Okay. Location index of Farah. That will return the first occurrence of this element Farah, which should be at index 3. I should return 3. And then we can remove that element by specifying its index 3. So after that, this element Farah is being removed. Remove 3, removed Farah. Okay, then print again. This is the new list. Okay, get function returns the object at a specified index 1. At index 1, it should be Kelly. So at index 1, it's Kelly, right? And size returns the number of elements in the list. Now it's 3. Okay, that's the common methods for array list. Okay, if you want to loop over the array list, you can also use for loops, while loops, right? Loop it one by one. But it's just, for example, a for loop using index, right? Index from 0 less than the size. When you visit each element, you should use the get function, right? That's a little different from array. It should be band dot get I, right? Get I. This will return the ith element from the array list. Okay. Okay. So it's different from arrays. In arrays, we usually use array like I, right, to visit the ith element. But in array list, you have to call the get function to visit a specific element. Array. That's different. Okay. All right. That's one example. Let's see another one. This recipe class stores and then prints the list of ingredients for a recipe. So we have several recipes, okay, which is kept in the several ingredients kept in the array list. Each element in this array list is a string type. So now in this array list, we specified the type of the elements in the list. It's different from that one, right? In this array list, we didn't really specify the type of the object. So two ways, both works. The difference is that, well, every elements in the array list is not necessarily to be the same. So it's different from array. In array, all the elements must be the same type, right? If it's an integer array, then all the elements should be integers. Right? A string array, all the elements is a string. But array list, the elements can be of different types. So it can be, it can be hybrid. Right? You don't need to specify the type of the elements in the array list. Right? If you don't want to do that, just create a general array list without specifying the type of the array elements. That works. So in that case, for example, I can also like add something like 1. Okay. That also works. It's a string type. This is an integer type, right? It doesn't matter because we didn't really specify the type of the elements in the list. So it can be mixed type, hybrid. But that doesn't always do a good job because sometimes we want to, loop over the array list and visit every element in the array list and do something to each element. If the elements of the array list are of different types, then we cannot apply, sometimes we cannot apply the same method to all the elements in the array list, right? So that may not be very helpful. So generally, we would create array list of a specified single type. Okay, for example, in this case, we created a list that only contains a string type elements, right? String type elements. Every element in the array list must be a string, otherwise that's error. That will cause an error. Okay, so when we do that, you have to use this this type of brackets, right, to specify the elements type. It's a string or it's an integer. If that is an integer, it should be something like this. Integer. Number array, let's say. All right, it should be something like this. Integer instead of int, not int, but integer. So the things inside should not be a primitive data type. If it's a primitive type, we have to use the wrapper class. Okay, so this integer class is a wrapper class, remember? It wraps the primitive data into a class type. So it looks like an object now. It's an integer object, right? It works like an object. So it has to be this type. Okay, because array list only contains objects. It cannot store primitive data types. So integer first being wrapped into an integer object. Double, if it's double, then being wrapped into a double object. Okay. If it's character, then character object. All right. It cannot be primitive data types. That's the type of the array list and new array list. Here, you don't need to specify the type again. You can just leave it blank. If you want to write it down, also works. It's not necessary. And you can also specify the initial size of the list, right? By like giving it 20 or 50, that's the initial size. If you do not do that, then by default, the initial size is 11 in Java. Okay. Usually we won't specify the size because it's dynamic. We don't know. Okay. So if we define the type of the elements in the list, then there's no way for us to store other types into the same list. That has some advantage if we want to apply the same method, right, to the elements of the list, or if we want to, for example, it's an array list of a student type, let's say, right, it's a student, all the elements are student objects, then we want to call the same method, right, for each student object. That's workable because they're the same type, they must have the same methods, right? Otherwise, if it's a hybrid array list, we cannot do it. It's not workable, right? So usually we will specify the type. Okay, now in this case, it's string type list, and we've added many elements in that. Each is a string. Print it out. The size should be 1, 2, 3, 4, 5, 6, 7. The size should be 7. And here we used an iterator to iterate over the list. That's another way. Instead of using a for loop, we can use an iterator. So iterator is another class that returns, that can construct an iterator object, which returns a list iterator. What does iterator do? Iterator basically stores all the elements. How do we say? Visit every element in the list one by one. If it still has a next one, then we can visit next one. So it has some methods like has next, which returns true or false. If it's true, then we have remaining elements that's not being visited yet. If that returns false, that means all the elements in the list is being visited. And then iterator dot next basically visits the next element. Okay, that's another way to do that. You can use the iterator or for loop using index. Doesn't matter. Okay, it's up to you. So this just gives you an alternative way to iterate the list. Okay, list iterator, that's the class name. A new iterator object, ingredients dot list iterator. Okay. While iterator has next, we print the next. So let's run it first. The result is very simple. It has 7 ingredients. 7 is the size of the list, and each element is being printed out. This list iterator only applies to list type, like array list. It doesn't apply, it's not applicable to array type, okay? It only is applicable to list, okay? All right. All these examples are from the textbook. You can also run it by yourself. So far, any questions? No? No question for me? Okay, if no question, let's take a 20 minutes break. Okay, so you can have some lunch, dinner, and we can go back at 6:52. Okay. Now that we've finished chapter 6, let's do some practice on that. I'll share the link with you. So it's the second practice. Consider a note-keeper object that is designed to store and manipulate a list of short notes. Here are some typical notes. A note is represented by the following class. Let's say this is the class and it has some methods, get note, that returns a one-line note. Okay, in other instance variables, constructor methods are not shown. A note keeper is represented by note keeper class. This note keeper class has a private instance, which is an array list of note types. Okay, of note types. The name is note list. This is a method print notes that prints all notes in the note list. We should implement that in part A. And the second one is remove notes, which removes all notes with specified string from note list. Okay. So part A, write note keeper method print notes. This method prints all of the notes in note list, one per line, and numbers the notes starting at 1. The output should look like this. So this one is a very basic question, right? We just need to loop over the list and print out every element. Okay. Since this is an in-class practice, I hope you can all write it by yourself and see if you understand it or not. You can type your solutions in the chat. Each element of the list is a note object. And remember, when you want to print the note out, you're supposed to use the get note function, right, which returns a one-line note. It's a string object. Okay. I'll give you another 1 or 2 minutes. Does anyone complete part A? No one? Is it too simple or too difficult? Any feedback? You can type 1 if you think that's too difficult. None of you type 1. Okay, then I'll randomly call someone. William Liu. William. Can you speak?
Hello.
Hello. Yeah. What is your solution?
Um, can you come back to me?
Okay. How about another William? William Bai. Okay. Thank you, William. Yes. Your answer is correct. Yeah. Do you mind if I post it to the public?
Sure.
Okay. All right, that's William's solution. That's correct. And it's nicely done. So for each element in the list, we need to use the get function, right, to find it. And then we need to use a loop to traverse the list, and then print out the format, right? But in this case, I don't know if William, you've run that in your Eclipse or not. I guess I'm not sure. The last line, system.out.print I plus 1 plus column, then temp.get. No, technically you should cast the I plus 1 into a string type first, and then attach it, connect the following strings to the first string. Otherwise, I plus 1 would be an integer type, right? Then append another string will be weird. So I'm not sure if Java would do that for you. Let's test it in the Eclipse. It seems like it's working. Yeah, it seems it works. Okay. That would be no problem. That's exactly correct answers. Good, then part B. Write the note keeper method remove notes. Method remove notes removes all notes from note list that contain the string specified by the parameter. The ordering of the remaining notes should be left unchanged. For example, suppose that notekeeper variable notes has note list containing the following things. The method called notes remove notes dog, okay, should modify the note list notes to be, so the one with a dog should be removed. And then the following would be in the same order: pickup, dry clean, car registration, dentist Monday, right? And the last one is removed. If note list contains, let's say the dot, or okay, if the string does not contains in the note list, then it should leave the list unchanged. If, for example, the note list contains pick up car, buy carrots, dog license, carpet cleaning, and then call the method notes remove notes car, right? And this should leave notes to be dog license. Why? Because car is a substring to the first element, pick up car. Second element, buy carrots. Carrots also contains the substring car. And then the last one, carpet cleaning, also contains this piece, CAR. So all three elements will be removed. Only dog license will be left. Okay, so that's this one. Public void remove notes takes in a string that's a substring. Okay, any elements that contains the substring should be removed. Okay. Once you finish, you can send your solution to me. Remember, in this specific case, you are not supposed to use the contains function, contains method of array list, because that function will return true only when the specified object contains, not piece of the object, or a substring of the string object. Okay, so in order to find whether the substring contains in the entire string, you will need to use some string method, right? And the other thing is, if you're using a for loop, indexed for loop, that might give you some problem. When you remove some elements, then the following elements index will also be changed, right? The size of the entire list will also be changed. So if it's a indexed for loop, that might have some problem. Does anyone have an idea? Grace? Do you have a solution? Hmm? You can send it to me if you're ready. Okay.
Not really sure.
I'm not really sure. Okay, I'll give you some more time. Does anyone? John? Do you have your solution ready?
Not yet. I made a
Hmm?
typo on it.
Sorry?
Not yet. I made a little error on it and I'm trying to fix it.
Okay. You can send it privately to me first. Jerry. Hi, Jerry.
Hello.
Yeah. Tell me, if the index for loop will cause trouble after removing some of the elements, right? How would you traverse the list?
I'm not really sure.
We have two types, right? Either a while loop or a for loop.
Then I think it's going to be for loop.
It could be a for loop, indexed for loop. But if we iterate starting from the beginning, the first element all the way to the end, then after, let's say, removing the first element, then the size of the array list will decrease by 1, right? Because the size is dynamic. Then the original second element now becomes the first, right? So the index for the second element now becomes 0. So how would you deal with that if you're using an index for loop? Because index for loop, the index will automatically increase by 1 after every iteration, right? Then probably you will skip the element because the following element will move forward, right? I believe we mentioned that once before. I'll give you some time to think about this.
Okay.
I think if you said before, I can just do the index for loop backwards, just like start from the end and then to the beginning.
You go backward, starting from the end, yeah. So after you're removing the element, that will not affect the elements before it, right? Yeah, that works. So that in that way, you can still use an indexed for loop. Okay, good. So how would you implement the body of the for loop then in order to check whether the node contains a substring, right? A specified substring or not? How would you implement that part?
I was gonna do dot contains, and then you said you couldn't, so I'm a little stuck there.
Oh, you can use contains for a string object, yeah. What I mean is you cannot use a contain method directly onto the array list, right? Because that will only check if the array list, node list, has the exact same string as the input string, right? So for example, the car, this example removes nodes car. If you only use contains applying to the array list, then it will only think the first one. No, actually none of these are the exact object, right? So it will return false, right? It doesn't really contain a node that's exactly the same as car. Yeah, for a string object, you can use contains if a string contains a piece of substring, right? You can use that. You can also use index of, find, right? Remember, we have several methods to use, yeah. Okay, I got one solution from William again. Use a while loop. I left the notes. I think that also works. I'll copy that to the chat. So this is William's solution. He used a while loop and an if-else statement in the loop body. If this note contains the substring, then we remove that. After removing that, in order not to skip the following notes, he does not increment the index I. If, however, that note is not the one we need to remove, then we increment the index. So this works. Yeah, that prevents you from skipping, right, some elements. I think this line is very good. The if statement line. If node list dot get I dot get node dot index of string not equal to -1. This is quite long. The first part, node list dot get I, returns the node object. The node object dot get node, which is this function in the node class, returns a string, right? That's the string, one line string. Then dot index of string checks whether that string node contains a substring string. If it contains that, then it will return the first occurrence of that substring, right? The index of the first occurrence, which would not be, which would be an index greater or equal to 0. Otherwise, if it does not contain that piece of substring, then it will return -1. So if it's not -1, that means it contains that substring. We remove I. Node list dot remove I. Remove the ith nodes. Yeah, that's perfect. Okay. You can also change the index of string function into contains string function, right? That also works. If contains string. Yeah, that can be changed to if node list dot get I, the nodes dot get node, the string dot contains string. That also works. This will return either true or false, right? Okay. Any question? All right, so this one is a basic practice. I hope you all can feel comfortable with this. All right. We still have some more time. This is another one. This question is quite long. In a certain school, students are permitted to enroll in one elective class from a list of electives offered. Because there are a limited number of spaces in each class for students, and because some electives are more popular than others, a lottery system was devised by the school to assign students to electives. Right? That's how every school works. Each student lists 3 choices for electives. Okay, the school orders the students randomly and assigns each student to the first available elective in the student's list of 3 choices. If none of the 3 choices is available, they might be fully enrolled, the school does not assign the student to an elective. After the school attempts to assign all of the students to the electives, it produces a list of students it was unable to assign. For example, suppose there are 6 electives available to students. These following 6. The following table shows the name, maximum enrollment, and current enrollment for the 6 electives after 64 students have been successfully assigned to the electives. Okay, so this is the table. So for the first one, astronomy, the maximum enrollment is 12 and it's full now. Right. The second, ballroom dance, maximum enrollment 20, current enrollment is 3, still have 17 spaces. The third one, I still have 1 more space. Okay. Note that 3 electives, astronomy, programming, marine biology, are fully enrolled, so they're no longer options for students. Any students that choose one of these 3 will not be assigned to them. Now suppose that the following students need to be assigned to the electives. Andrew chose programming, marine biology, and ballroom dance. Then its first and second choices are fully enrolled, right? Programming, marine biology, both fully enrolled. Only the third one has openings. So Andrew will be enrolled in ballroom dance. David, the first choice is constitutional law, still has openings, so will be enrolled in that. All 3 of Elizabeth's choices are fully enrolled, so Elizabeth will remain unassigned to elective. Ethan, the first choice has 1 opening left. Ethan will be enrolled in basket weaving. Now, basket weaving is fully enrolled after Ethan is enrolled. Then Catherine comes. Catherine chose programming, basket weaving, marine biology. After Ethan is enrolled, all 3 of Catherine's choices are now fully enrolled. So Catherine will also be unassigned, right? So both Elizabeth and Catherine will be unassigned. Okay, in this problem, the school is modeled by the class school. Students and electives are modeled by classes student and elective. The school class includes the following methods. The student list, which is an array list that holds the list of students in the order in which the students should be scheduled. Then elective list, also an array list, holds the electives that students may choose. Then 3 other methods. Get elective by name. This returns the elective in elective list with the given name. Assign electives to students method. This method encapsulates the functionality of assigning student their first, second, or third elective choice. And third one, student without electives. This method will return an array list containing students that have not been assigned to any elective. Okay, so this is the school class. And the student class includes the following methods and private data. First, get choice. This method returns the name of the given elective choice of the student. Okay, the first elective choice has index 0, the second index 1, and third index 2. Okay, all right, it returns names, right? Has elective, this returns true if the student has been assigned, otherwise false. If the students remain unassigned, then it's false. Assign elective, this method assigns the given elective to the student. Okay, so that's the 3 methods. The last class, elective, that has a method get name, returns the name of this elective. Get max class size returns the maximum number of students for the class. Get class size returns the current enrolled. Okay, that returns the number of students that have been assigned. Add student that assigns the given student to the elective. Okay, so this is the elective class. It also has those private instances, string name of the class, maximum class size, current class size, and a list of the students who are in this class. Okay. The first part, we need to write the school method get elective by name. This method should return the elective in elective list that has the given name. Okay. Precondition, name is the name of an elective in elective list. Postcondition returns the elective in the elective list with the given name. So let's go back to see the elective list in the school class. Elective list is an array list, and the element of the list is elective objects. Okay, elective object. So get elective by name will return the object given the name. For example, get elective by name astronomy, that will return the astronomy object, right? That elective object with the name. And you don't need to worry about how the elective object work. Let's assume everything works fine. Okay, so in the elective class, it do have the class name, right? As a private string name. And it also has the get name function, which is an accessor, right? An accessor that returns the name of the elective. Okay. So let's first do the part A, implement get elective by name. Since it's a list, right, elective list, we still need to check object by object, right, element by element. So still need to traverse the whole list. Every element in the list is an elective object. So we need to compare the name of that object with the target name. If they're the same, then we return this object, right, this elective object. Otherwise, we keep on moving to the following objects. That's the basic idea. So if you have the algorithm in your mind or the pseudocode in your mind, you just need to implement first a loop to traverse the list, right? And then get each element of the list. Since each element is elective object, how would you compare that with a name string? You need to get the name of that elective object, right? Using the accessor get name, right? That returns the name of the elective, and compare this elective object's name to the target name. Since both are string object, how would you compare that? You should not use the double equal sign, right? You should use the string method dot equal. Compare if they are equal. If they're equal, then basically return this elective object, right? Otherwise, move on. So this is quite simple. Any question about the pseudocode? Any question? If no, I'll give you 1 minute okay, to quickly type the solution out. All right. Who's ready? Caitlin?
I still need a bit more time.
Okay. Take your time. The free response questions in our final test will be very similar to those practices we did in class. Okay, so I hope you can practice by yourself. Anna, how about you?
I'm not sure.
Not sure? Not sure about the algorithm? About Sudoku? Or not
Yeah.
sure how to write it out?
I think I'm not sure how to write it out.
Not sure how to write it out. Okay. So you understand the pseudocode, right? First using a loop, either a for loop or a while loop to
Yeah.
traverse the list, right? And for each element of the list that's an elective object, we use the getName accessor, right? GetName method to get the name of that object, the current object, and compare that with the target string name using the dot equal method. If two strings are the same, then we return this object. Otherwise, we do nothing, we just move on, right?
Yeah.
Caitlin, now are you ready?
Not yet.
Which part do you find difficult?
I'm not really sure how to like um
How to get the element of the list?
yeah.
Okay, you just use dot get method. Dot get. I'll copy William's answer again. Thank you, William, for sending your solutions. I'll copy that. So this is the one. Where should I put it? Here. Okay, this one. So a loop, right? A for loop. That's the basic one. You need to know how to write it. A for loop with an index starting from 0 all the way to the end, right? Then the ending condition is when I less than the size of the list. You just use dot size to get the size of list. Then I plus plus. That's the structure of for loop, right? And within the for loop, we need to check whether this current element has the same name as the target or not. So we use the list name dot get I that gets the ith element of the list, which returns an elective object. And that object has a get name method, right? That's the accessor for the elective object, which returns the string type name of the elective object. And after this, we have a string. Now we need to compare this string with this input string name. Compare two string, we need to use the dot equals method. If these two strings are of the same value, this returns true. If that's true, meaning we find the correct elective object, we simply need to return that object. I remember the object is from the list, and that's the ith element in the list. So simply return elective list dot get I Okay. So, any question? No, right? Okay, let's do the following. Part B, part C, we still have two parts. Part B, write the school method assign electives to students. Method assign elective to students should assign electives to student as described. So meaning if the class still has opening space, then we can assign to that student, right? Otherwise, no, right? So you may use the private helper function method, get elective by name in part A, assume that it works as specified, okay? And it can also contain other helper functions if needed. So the post condition for this method is all students in the student list have been either assigned their first available elective choice or not assigned. All electives in the elective list have been updated appropriately as students are assigned to them. This one is a little complicated. We need to first write out the pseudocode or the algorithm before you type in the solution. Okay. So what's the pseudocode? This assign elective to student method takes in nothing and returns nothing. It's just after calling that, all the students should be properly assigned to elective, meaning the array, meaning all the elective object should be properly updated, because for elective object, it would have this private instance class size, right? Let's say now it has more students coming in, enrolled in this class, then the class size of this elective object will need to be updated, right? As well as the student list in this class also will need to be updated, okay? And for the student, well, each student object also need to be updated because, well, it doesn't show any private data fields here. Well, then that doesn't matter because we don't have any private data fields here. So that means we only need to update the electives, okay, which keeps the class size and the student list. All right, how will we do that? Well, we first need to get student by student, right? One by one, assign each student from the by the order in the list, in the student list, right? We have a student list. Then we go to each student object and check the student. Let's say the first student object is Andrew, right? Go to the first object Andrew. And for each student object, we can use the get choice, right? Get choice to return the name of the given elective choice. Let's say for Andrew, we call get choice 0. Get choice 0, this returns his first choice, right? So this will return programming. Then once we have the name of the choice, the first choice of Andrew, we check by the name of the elective if that class still has space opening, right? And remember, we just implemented the get elective by name method in part A, right? So we can use that, which returns the elective object of that name. And then we just need to check if the current class size reaches the maximum. If it's true, and the class is full. Otherwise, we still can add that student to this elective. So we increment this current class size and add the student object to the student list in that elective object. Okay, that's the pseudocode. It might sound a little complicated, but I guess you can write it out line by line using pseudocode and then type out the solutions. So basically we'll need a loop, right, to traverse over the student list. Each student should be assigned. For every student, since they have 3 options, 3 choices, right? So you probably need a loop, another loop to get each choice. If the first choice doesn't work, go to the second choice. If the second choice doesn't work, go to the third choice, right? And how to check whether each choice works or not? We should use the choice name, right? The name of the class, and check if the elective object reaches its maximum class size or not, right? Okay. So some if-else statement. If it reaches the maximum, then we move on to the second choice. If it doesn't reach the maximum size, still has some space opening, then we add that student object to this elective object, student list, right? Add to this student list by using add student, right? Remember, we have a add student method. That's a helper function. You just assume that works, okay? It will assign the student to this elective. After that, the student is being added to this list, and then don't forget to increment the class size. Okay. All right, we don't have more time left, so I'll include this practice in your homework so that you can practice by yourself. All right. Any other question for me about this chapter or about the project? Any feedback, comments? How many of you think you need one more lesson on this chapter to review things? You can type 1 if you think you need one more review class on this chapter. If no, next time I will review mainly on the previous chapters class. Of course, I will review this array list. Okay, so some of you still think you need more time too. Okay, so next time we'll first review this chapter, array, and then we'll also cover previous chapters. Okay, see you next week then. Get prepared for the test.
And for the project one, because I wasn't at home during the Thanksgiving break, so I may still need like 1 or 2 days.
Okay, no problem.
Thank you.
All right, see you next week. Bye.
Yeah.